Hi everybody. So in this video we're going to look at finding the mean and the standard deviation using the standard normal distribution. So in this example, we're told that the operational life of batteries produced by one manufacturer can be assumed to be normally distributed. We've been told that 10% of batteries take at least 40 hours until failure and 0.5% take less than 8 hours. We've been asked to work out the mean and the standard deviation of the operational life of batteries produced by this manufacturer. So if we begin by stating our model, we can say that X is distributed normally with a mean of mu and a variance of sigma squared. I know it's important to define what X is, and this is where X is the random variable, the number of hours of battery life. So if we begin with this statement, where 10% of batteries take less than 40 hours until failure, then we can show this on a normal distribution curve. So what we have then is the probability that X is greater than or equal to 40 is equal to 0.1. So if we have our mean here, then we know the 40 will be on this side. So we'll mark this off as 40, and this area is 0.1. And we're also told that 0.5% take less than 8 hours. So we can show this on a normal distribution curve as well. And this is where the probability of X is less than 8. And this has a probability of 0.005. So we've got our average. And this will be on the left-hand side, we'll say about here. And this region will have an area of 0.005. So to work out the mean and the standard deviation, we need to create an equation using these two situations, and this is where we'll use the standard normal. So to transform this distribution x onto the standard normal, we'll use the equation z is equal to x minus the mean over sigma. And we know that z is distributed normally with a mean of 0 and a variance of 1 squared, or a standard deviation of just 1. So now to work out this z for each of these two situations, we need to use the inverse normal. So if we go to our calculators, we'll press menu and then number 7 for distribution. We want option 3 for the inverse normal. Now in our blue situation, we've got an area of 0.1, but the calculator uses the area to the left, which starts from 0. So for area for this case, I'm going to put in this value, which is 0.9. And sigma we know is 1, mu we know is 0. So in this case, z will equal 1.28. So now we'll substitute this value for z back into our equation. We get 1.28 will equal x, and x in this case is 40, minus mu over sigma. We can move this sigma to the left-hand side, and move this negative mu to the left-hand side, and this will equal 40. So this is our first equation. We can use the same idea for the other situation. We go back to standard normal. The area is now 0.005. Sigma and mu remain the same. So in this case, z will be equal to negative 2.58. So we'll substitute this into the equation. Negative 2.58 will equal the x value minus the mean over sigma. We'll move the sigma to the left-hand side, and we'll add mu to both sides. So negative 2.58 sigma plus mu will equal 8. And this will be our second equation. And now we can solve these two equations simultaneously. If we go to menu, we want the equation solver, one for simultaneous equations with two unknowns. The coefficient of sigma is 1.28, the coefficient of mu is 1, and the constant is 40. For our second equation, the coefficient is negative 2.58, the coefficient of mu is 1, and our constant this time is 8. So we can see the standard deviation is 8.29 and the mean is 29.39. Okay, well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.